Hi. In lower classes, you have already learned how to find HCF and LCM of two positive integers using fundamental theorem of arithmetic without actually realizing it. Yes, you used to call that method as the method of prime factorization. Let me take an example to revise it. So let's say the question is, find the HCF and the LCM of 36 and 96 by prime factorization method. For this, we need to prime factorize the given number 36 as well as 96. So let's prime factorize 36. We'll stretch a bar out here and out here. We'll divide it by the lowest prime number, which is 2, because it's divisible by 2. We'll get 18. We'll again divide it by 2 because 18 is again divisible by 2. We'll get 9. 9 is divisible by 3, so we'll divide it by 3. We'll get 3, which is further divisible by 3. We'll get 1. Therefore, we can write 36 as 2 times 2 times 3 times 3. Or we can write this 36 as 2 squared times 3 squared. Similarly, we can prime factorize 96. So let's try and do it. So if I prime factorize 96, I again need to stretch this line down and I'll divide this 96 by 2. I'll get 48, which can be which is actually divisible by 2. So we'll get 24. 24 is further divisible by 2. We'll get 12. Again, divisible by 2 will divide, we'll get 6. Again, this is divisible by 2, we'll get 3, which can further be written as 3 times 1. Therefore, we can write this 96 as product of all these values. 2 times 2 times 2 times 2 times 2 times 5. So 2 is multiplied 5 times, hence 2 to the power 5 times 3 to the power 1, you may say. Now over here, we need to find the HCF and the LCM. In order to find HCF, what do we need to do? So HCF of these two values, 36 and 96. 36 and 96. So in order to find the HCF, we need to choose the smallest power of each common prime factor. So 2 as well as 3 are common prime factors. We'll choose the smallest power, which in this case is 2 and in this case is 1, and take the product of these two values. So let's try and express it down. So we'll say 2 squared will come from 36 and a 3 to the power 1 will come from 96. 3 to the power 1. So if I multiply these two values, I will be able to get the HCF, which in this case 4 times 3 turns out to be 12. So this turns out to be the HCF of 36 and 96. Hence you can remember this, that the HCF is nothing but the product of the smallest power of each common prime factors in the number. Now let's find out the LCM. Now in order to find the LCM, let me first write it. So LCM of these two values, 36 and 96. Now, in order to find the LCM, what do we need to do? We need to take the product of the greatest power of each prime factors involved in the number. And mind it, I'm talking about each prime factors involved over here. Over here, 2 and 3 are the total prime numbers involved amongst these two numbers, 36 as well as 96. So we'll choose the highest power of 2 as well as the highest power of 3. So from 36, we're going to get 3 squared, and from 96, we're going to get 2 to the power 5. So we'll put it over here, 2 to the power 5 from 96 and 3 squared from 36. When being multiplied, will give me the LCM, which in this case will be 288. Hence, remember that the LCM will be the product of the greatest power of each prime factor involved in the number. Now here, you can notice one relationship between HCF, LCM, and the given numbers, which in this case are 36 and 96. Now if you multiply 12 by 288, let me do it over here. So if you multiply 12 by 288, you will actually get the same product if you multiply 36 by 96. So both the values will be equal to each other. They will be 3,456. Therefore, you can conclude one simple relationship between HCF, LCM and the given numbers, and that is HCF when being multiplied by the LCM will be equal to the given two numbers. So if I'm taking the HCF and the LCM of A and B, where A and B are positive integers, remember this is an important part, where A and B are positive integers, then the product of HCF and LCM will also be equal to the product of the given numbers. There is also a note which you need to remember, a very, very important point and a crucial point for this relationship which you need to remember is that this relationship is valid only for two positive integers. Hence, you can write it down over here that this result is valid only for two positive integers. The symbol represents positive. So it has to be two positive integers. Now this was all about HCF and LCM and one basic relationship between HCF and LCM and the given two numbers.